Okay, this looks like a very fun problem to me. All right. Of course, my idea of fun is probably not yours. But anyway, let's take a look at how I screwed this up when I first did it. And I was glad that I looked at it again because I would have thrown you way off track. I was going, oh, okay, well, this is 15 uh, meters high, the water here. Right away, I'm wrong. Okay, we got a vent up here. So the vent's all the way up here. So that means I got to figure out the dang diameter of this water tower. Okay, and then, first of all, is the pressure going to be higher in A or in B? I hope you said A. The pressure will be higher in A because it's the pressure in A is going to be the same as the pressure here, and the pressure in B is going to be the same as the pressure here. And so now we've got to solve. The only tricky part that we have to do is we have to figure out what the diameter of this ball is so I can figure out what the total height is. All right? Because it all boils down to this. It all boils down to, this is problem what, 27? So for 27, it all boils down to this. You got this water tower. Okay? And then the water comes up here. And some of your distances are going to be, heights are going to be different, 15 meters, right? And the vent here, so the water coming in here, then the water going into this house, right? And the water going into this house. All right? So the pressure here is the same as the pressure there. And the pressure there is just equal to P1 plus rho GH. And the pressure here is equal to P1, so of house A. Wait, oh, hold on. I want to make sure I get the houses. Okay, of house B. So this is house A. Ah, God dang it. Then this is house A. Okay, so this is house A and this is house B. Why I don't know why they do that, because we read from right to left. So the pressure in house B plus the pressure in house A that's it. That's it. Where we know that P1 is equal to 1.013 times 10 to the fifth pascals. And now don't think that's this whole height here is 15 meters. Okay. And we got to figure out this extra diameter of the sphere. All right. And don't forget, rho of water is equal to 1,000 kilograms per meters cubed. And we know that the volume of a sphere is equal to 4/3 pi r cubed. Okay, now how the heck are we going to figure out the volume of that sphere? Well, I think, did they tell us the mass of the water? The mass of the water is 3.14 times, yes, they did. Bless their hearts. Which is going to equal, so the mass of the water is going to equal the density times the volume. So you had to put a couple things together there. All right. So this is given. This is given. This is not given, but you're going to use this to solve for r cubed. So it's a little tricky. It's not a gimme, but that's how you set it up. This part looks really simple. Okay, so now you understand that. You're like, okay, I get that. But then they throw in this little thing where you got to solve for the volume of the sphere. Okay, good, nice problem. Little public works.